बच्चों अब मैं केमिस्ट्री की यूनिट 12 ऑर्गेनिक केमिस्ट्री सम बेसिक प्रिंसिपल्स एंड टेक्निक्स की ऑब्जेक्टिव्स और समरी आपको बताऊंगी. After studying this unit, you will be able to understand reasons for tetravalency of carbon and shapes of organic molecules. You will be able to write structures of organic molecules in various ways. You will classify the organic compounds. Name the compounds according to IUPAC system and nomenclature and also derive their structures from the given names. Understand the concept of organic reaction mechanism. Explain the influence of electronic displacements on structure and reactivity of organic compounds. Recognize the type of organic reactions. Learn the techniques of purification of organic compounds and write the chemical reaction involved in the qualitative analysis of organic compounds. You will be able to understand the principles involved in quantitative analysis of organic compounds also. Now I will read summary for you. It's a big chapter, so it will take time to complete the summary of the chapter. In this unit, we have learnt some basic concepts in structure and reactivity of organic compounds, which are formed due to covalent bonding. The nature of covalent bonding in organic compounds can be described in terms of orbital hybridization concept. In organic compound, according to which carbon can have sp3, sp2 and sp hybridized orbitals. The sp3, sp2 and sp hybridized carbons are found in compounds like methane, ethene and ethine respectively. The tetrahedral shape of methane, planar shape of ethene and linear shape of ethine can be understood on the basis of this concept. A sp3 hybrid orbital can overlap with one s orbital of hydrogen to give a carbon hydrogen CH single bond sigma. Overlap of a sp2 orbital of one carbon with sp2 orbital of another result in the formation of a carbon-carbon sigma bond. The unhybridized p orbital on two adjacent carbon can undergo lateral side-by-side overlap to give a pi bond. Organic compounds can be represented by various structural formulas. The three-dimensional representation of organic compounds on paper can be drawn by Wedge and Dash formula. Organic compounds can be classified on the basis of their structure or the functional groups they contain. A functional group is an atom or groups of atoms bonded together in a unique fashion and which determines the physical and chemical properties of the compounds. The naming of the organic compounds is carried out by following a set of rules laid down by the International Union of Pure and Applied Chemistry IUPAC. In IUPAC nomenclature, the names are correlated with the structure in such a way that the reader can deduce the structure from the name. Organic reaction mechanism concepts are based on the structure of the substrate molecule, fission of a covalent bond, the attacking reagents, the electron displacement effects, and the conditions of the reaction. These organic reactions involve breaking and making of covalent bonds. A covalent bond may be cleaved in heterolytic or homolytic fashion. A heterolytic cleavage yields carbocation or carbanion, while a homolytic cleavage gives free radicals or reactive intermediates. Reactions proceeding through heterolytic cleavage involve the complementary pairs of reactive species. These are electron pair donor known as nucleophile and an electron pair acceptor known as electrophile. The inductive resonance, electromeric, and hyperconjugation effects may help in the polarization of a bond, making certain carbon atom or other atom position as places of low or high electron densities. Organic reactions can be broadly classified into following types: substitution reaction, addition reaction, elimination reaction, and rearrangement reactions. Purification, qualitative and quantitative analysis of organic compounds are carried out for determining their structures. The methods of purification, namely sublimation, distillation, differentiation, differential extraction, are based on the difference in one or more physical properties. Chromatography is a useful technique of separation, identification, and purification of compounds. It is classified into two categories: absorption and partition chromatography. Adsorption chromatography is based on differential adsorption of various components of a mixture on an adsorbent. Partition chromatography involves continuous partitioning of component of a mixture between stationary and mobile phase. After getting the compound in a pure form, its qualitative analysis is carried out by for detection of elements present in it. Nitrogen, sulfur, halogen, phosphorus are detected by Lessane test. Carbon and hydrogen are estimated by determining the amounts of carbon dioxide and water produced. Nitrogen is estimated by Dumas or Delja's method and halogens by Carrier's method. Sulfur and phosphorus are estimated by oxidizing them to sulfuric and phosphoric acid respectively. The percentage of oxygen is usually determined by difference between the total percentage and the sum of percentage of all the other elements present. So this was all about the chapter organic compounds, organic chemistry, basic principles and techniques. And there are 40 questions given at the back. Do all the questions and your chapter will be ready after reading 2-3 times and doing all the exercise given in between. Don't be afraid of this chapter.